Hello, my name is Angela Martinek. I'm your instructor for Math60 at Lane Community College Summer Session 2012. We'll be using the Blitzer 3rd edition Introductory and Intermediate Algebra book, and this is section 1.1. At this point, I want you to pause this video and read section 1.1 in your text. Don't worry about understanding it. Don't worry about being able to do any of the problems just now. Just read it like you would a novel. All right, you should have found there were about 3 or 4 main points. I'm going to go through several of those right now. In fact, I'm going to discuss at this point, get a pen, I'm going to discuss variables, expressions, algebraic expressions, some translation from words to algebraic expressions, and also talk about equations. These are the key points in this section of section 1.1. It's important that you read the book before watching these videos. I'm only going to cover very briefly the key points in the sections. So the first one is a variable. Variables are used in mathematics as placeholders. They specify a location for a number. They say, I'm going to put a number here. I'm not sure what it is yet, so I'll just call it x. X sometimes gets overused. We can use t, we can use y, all sorts of letters. Any letter really can be used for a variable. If I wanted to multiply a variable by a number, say 3, multiplied by some number, say x, all right, if a number is put next to a variable, it means multiplication. In order to know 3 times something, the big question is, well, what is this? Right? If I knew what x was, I could tell you what 3 times it was. So let's let x equal 2. Well then you say, all right, well 3x then would be 3 times 2, which is clearly 6. All right, so this variable gets used. A number gets put in its place. It gets substituted in for that variable. There's a lot of English words we use in mathematics, and we translate those words into expressions. So 3 times x or 3x, 3 multiplied by x, all of these mean 3 times x. But we could also say 3 times a number, and I might just put in an x. Expressions. That's another key point that get brought up in this particular section. Expressions are something like 2y. That means 2 times y, and it's called an expression in mathematics because there's no equal sign. But that's not the only reason. Let me give you another expression, square root of t. We can get quite elaborate with these. 3y divided by the square root of x. All kinds of things. We could say 2x minus 5. All of these are expressions in mathematics. Expressions are a combination of a number, a variable, and an operation. So in this case, we have 2 as the number, y is the variable, and the operation, that's right, multiplication. So here's an expression, 2x minus 5. Perfectly fine expression. You should come up with some of your favorites as the course goes on. What we do with expressions is we're able to evaluate them. Evaluating an expression means I assign a value to the variable. All right, that's the first thing I do. And then the second thing I do is perform the operations. All right, so 2x minus 5 at, say, x is equal to, well, it's a variable, so I'll pick 7. Nice number. So 2x minus 5 is equal to 2. Now I'm going to replace x with 7. Right? That's what we said. So now 2 times x, well, x has a value now of 7 minus 5. Now I'll perform this operation. Multiplication before subtraction, so it's 14 minus 5 is equal to 9. So we've evaluated this expression, 2x minus 5 at x equals 7 is equal to 9. Very important in mathematics are equations, sometimes called formulas. An equation equates two expressions. It has sides, what we call sides. This symbol, this parallel lines here, the parallel line symbol, is what's used to show that we have an equation. An equation is a statement that's either true or false. For instance, x equals 5 is a fine equation, and it's true if x equals 5. Why? Well, because if I replace over here this x with 5, I get 5 equals 5, and we know that to be true. But it's false if x equals anything else, say 3. Because when I replace x with 3, I find that 3 equals 5? No, 3 does not equal 5. The line through this equation symbol means not equal to, so I would say 3 does not equal 5. Here's an example. X plus 3 is equal to 10. We could say this is a number. This is a sum. This, of course, is just 3. We could replace this with the word is, and 10. So I could state this as the sum of a number and 3 is 10. Let's solve this. X plus 3 equals 10. The solution to an equation are the values, sometimes more than one, given to the variable to the variable that make the equation true. So in this case, the solution is 7, because 7 plus 3 equals 10, or 10 equals 10. Okay, at this point I'd like you to go back to your textbook and do the checkpoint problems. Once you feel comfortable with those, you may start on the homework.